Today we discuss one important topics related to real analysis. We start today as sequence. Okay, we start from definition. Right here definition first. Okay, a mapping if n to r natural number set to real number set. Okay, is said to be a sequence in R or a real sequence okay, that means one mapping if natural number set to real number set, we call this mapping one sequence, okay, or real sequence. Then also going to discussion some example of some sequence. So we start from here. If n to r defined by if n equal to n, okay, then what happen here? If 1 equal to 1, if 2 equal to 2, if 3 equal to 3, in this way we get one sequence. We write it in second bracket singleton n, okay, this one in this way 1 2 3 dot 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 represent this set, okay, set of elements. And we also write this one are image of f, okay, that means this one are image set of f, and we call this mapping f be a sequence, okay. So here we also taken another example. If n to r, here if n equal to n divided by n plus 1, okay, n belongs to natural number set, then what happened here? Then f1 equal to half, f2 equal to 2/3, and dot dot dot, here in this way f3 equal to 3/4, and then we also get one set of elements here n by n plus 1, here half, 2/3, 3/4, here 4/5, 5/6, dot dot dot, okay, that means this one converts to 1, okay, and this sequence also converts to plus infinity, okay, that means this one are divergent sequence. Also discuss, then after some time we discuss this one convergent sequence or not. Now we also going to another example, okay, we erase that portion and going to further another example of this sequence. So here we write if n to r, if n equal to sin n pi/2, okay, then f1 equal to what? Sin pi/2, sin pi/2 equal to 1, and f2 equal to what? Sin pi equal to 0, f3 equal to what? Sin 3 pi/2 equal to what? Equal to pi plus pi/2 minus 1, okay. Next, in this way, we also write if 4 equal to what? If 4 equal to sine 2 pi equal to 0. If 5 equal to what? Sine 5 pi by 2. Okay. That means 2 pi plus pi by 2, 1. Yeah, if 6 equal to sine 3 pi equal to 0. If 7 equal to, in this way, sine 7 pi by 2 minus 1. Okay. So we write this one, this sequence sine n pi by 2 here, just 1 0 minus 1. Okay. So we give example of three sequence and this definition of sequence or real sequence. Okay. And now we are going to discussion another part, convergent sequence. Okay. Now we write here, we erase this lower portion also. We write convergent sequence. Okay. A real sequence, a real sequence if n, okay, is said to be a convergent sequence, is said to be a convergent sequence if it has a, if it has a limit L belongs to R, okay, then it is, that means if n converges to L, okay, as n tending to infinite plus infinite. Okay, so we write in this way, limit n tending to plus infinite if n equal to L. Otherwise, that means it was a divergent sequence. That means L, if L tending to plus infinite or minus infinite, then this one are divergent sequence. Okay, so we write here, that means first sequence if n equal to n, this one are converge to what? Plus infinite. Okay, that means this one are divergent sequence. And next one are if n equal to n by n plus 1. Okay, this one convergent sequence. That means we write limit if n tending to infinite equal to limit 1 by 1 plus 1 by n tending to infinite. Okay, then 1 by n equal tends to 0, this one equal to 1, so this fn converts to 1. And this one also, this one, I think divergent sequence, that means sometimes it converts to 0 and sometimes converts to 1, sometimes converts to minus 1. Okay, so also write this one equal to minus 1 whole to the power n. Okay, then what happened with just 1 and minus 1 of 10. Okay, this one are one sequence, this one a divergent sequence, and obviously this one bounded. Okay, this one bounded sequence. that means sequence bounded but not convergent. Okay, and this one also bounded sequence but not convergent. So we also write here another example of convergent sequence. Wait, here's our portion and going to further discussion of that. Okay. Here, if n equal to 2, okay, for all n belongs to n, then what happen if 1 equal to 2, if 2 equal to 2, dot dot dot, okay, limit n tending to infinite if n equal to 2. So if n converts to 2 as n tending to plus infinite, okay. So this one are constant sequence and obviously convergent. Now we write another example. Here if n equal to n square divided by n square plus 1, okay, then what happened here if 1 equal to 1 by 1 square plus 1 equal to 2, if 2 equal to what 4 by 5, if 3 equal to what 9 by 10, okay. In this way we write limit n tending to infinite plus infinite if n equal to limit n tending to plus infinite 1 by 1 plus 1 by n square, okay, then this one equal to 1. So this sequence obviously if n converts to 1. So today we discuss sequence and example of some sequences and convergent sequences, okay, and example of convergent sequences. One basic tool in real analysis, okay. So today we discuss this one. I think all understand this one easily and suitably. If you get this type of video, please subscribe my channel, follow my channel, see this video regularly and click on like options. Today I stop here. Thank you.